everyone, I am Ganga Devi from the Standard Fire Oaks Rajaratnam College for Women. In this tutorial, we are going to see the next data structure, binary tree. So, what is a binary tree? It is the non-linear data structure, that the one we are going to see now. So, till now we have seen the linear data structures, but now it is the non-linear data structure, because here nodes are, the data are stored as nodes and they are connected to each other through edges, and these elements are having only one path between any two nodes. They are arranged like that, they are following the hierarchical way of representation, and so it is very useful for, that is, it is easy for navigating as well as for searching. So, a tree with only two children is called the binary tree. So, today we are going to see the binary tree only. The terminologies that are used in trees are as follows. The first one is the root. So, the root is the topmost node which is available in every tree. Okay. So, next is the parent and children. So, who is the parent? The parent is the topmost node and children are the two sub branches from emerged from that parent. Okay. So, next one is the leaf nodes. The leaf nodes are the terminal nodes. They are not having any other children from that nodes. Okay. These nodes are called the leaf nodes. So, next one is the siblings. Siblings means the nodes that are emerged from a single parent. These are called the siblings. Here, for example, B and C are the siblings and E and F are the siblings. Okay. So, apart from these things, we have some other terminologies. One is the levels. So, each and every nodes are coming under one level. For example, the root node is always starts from 0th level. Here in this tree, B and C comes under first level and E and F are comes under third level. So, depending upon the levels, we have some more terminologies. First one is the degree. So, degree of a node is the number of branches that are emerged from that node. Okay, that is number of children they are having is the degree of a node. So, as usual, leaf nodes are having no children. So, the degree of leaf node is 0. Apart from that, degree of A is 2. It's have 2 children, right? And degree of B is only 1. It's have only 1 children D. So, totally the degree of the tree is the maximum number of degree, which is 2. So, next one is the height. So, height of a particular node is representing from the position they are to the end. Okay. So, here the height of A is 3 and B and C is 2. That is, always height will be represented using the levels only. So, here the maximum height of a node is 3. So, the height of the tree is 3. So, depth is the reverse of the height. So, height represents the tallest position they are occupying, depth represents the depth they are involving in the tree. Okay. So, depth of root node is always 0, that is we are starting from there only, right. So, depth of root node is 0, depth of leaf nodes are 3 in this tree. So, the depth of the whole tree is again 3. So, how we can represent the binary tree? So, in C we will represent the binary tree as a structure. So, here we are going to represent it as a node, right. So, here the node is having the data at the center and it is having 2 pointers to represent the left child and the right child. So, in C, if you are going to declare it, we have to declare it as a integer data, that is, a data is a variable, and after that we have to represent the self-referential structure pointers like star left and star right. So, the tree is represented as a C pointer as shown in this diagram. Okay. So, next one is we are going to see the types of binary tree. So, first type is complete binary tree. Here in this PPT we are having 3 different images. So, which one is the complete binary tree? So, here in the among these 3, the first one is the complete binary tree. Why means binary tree, complete binary tree must contain fully filled nodes at all levels except the last level. That is, at all levels it should contain all the possible nodes, but at the end of the level it should contain the nodes which should be filled from left side to the right side. So, the first one is the complete binary tree. If you are seeing the middle tree, means there all levels are filled, but at the last level it is not getting filled from left to right, it is filling from the right side only. That is leftmost children are missing, right. So, it is not a complete binary tree, and in the third binary tree at the level 1, one node is missing. So, it is also not a complete binary tree. So, next type of binary tree is full binary tree. Here we have two trees. Which one is the full binary tree? Is the left side tree is the full binary tree. That is binary tree if it is a full binary tree, then each and every node must contain either 0 or 2 children. It is not allowed to have only one children, but at the left side image you can see that at the level 2 one node is having only one children at the level 2, right. So, it is not a full binary tree. First tree is the full binary tree. Okay. Then next type of binary tree is skewed binary tree. Skewed binary tree means here all the nodes are having only one children, or else it is not having any children. Okay. So, again also the first one is not the skewed binary tree, because there some nodes are having 2 children, right. For example, root is also having 2 children. So, it is not a skewed binary tree. Second one is the skewed binary tree. Okay. So, now we are going to see some of the properties of binary trees. The first property is the maximum number of nodes at level L of the tree is 2 to the power L. Let me see whether it is true or not. Okay. We have 2 trees are here, right. So, we are also providing the levels also. At the level 0 you can see every trees are having only one root node, right. So, 2 to the power 0 is 1. That is all. So, at the level 1 you can see that 2 to the power level 1 means 2 to the power 1 is equal to 2. That is at the level 1 position the maximum number of nodes should be 2. You can see that evidently from this diagram. At level 2 the maximum number of nodes allowed should be 4. You can see that also, right. So, the second property is the maximum number of nodes in a binary tree of height h is 2 to the power h minus 1. Let me see that again. So, here in the first tree the height of the tree is 2, you can see that, right. So, the height of the tree is 2, that means 2 to the power 2 minus 1 which is equal to 4 minus 1 which is equal to 3. So, in the first tree the maximum number of nodes is 3, and also from the second diagram if you evaluate as shown that in that PPT, the maximum number of allowed nodes is 7. You can see that from the diagram also, right. So, the next property is in a non-empty binary tree. That is, in a binary tree, if n is the total number of nodes and e is the total number of edges, then the number of edges is equal to the number of nodes minus 1. That is, always the number of edges is 1 less than the number of nodes in that tree. So, let me see that. Here in the first tree the number of nodes is 3 and the number of edges is 3 minus 1 2. You can see that in the diagram there are 2 edges only in that diagram, and also in the next diagram you can see that the number of nodes is 7, that means the edges should be 7 minus 1 6, right. Yes, of course it is followed there. Okay. The next property is in a full binary tree. You all know what is a full binary tree? That is a tree with nodes having either 0 or 2 children. There is no one children is allowed, right. So, in the full binary tree the number of leaf nodes in that tree must be equal to the number of internal nodes plus 1. So, see the diagram, in the first binary tree there is 2 leaf nodes are there and only one, that is internal nodes means the nodes other than the leaf nodes, only one internal node is there, right. In the second diagram we have number of leaf nodes as 4. So, the internal nodes should be minus 1, that is 3. Either you can calculate it from internal to leaf or leaf to internal, that is plus 1, number of internal nodes plus 1 leads to leaf node, or number of leaf nodes minus 1 leads to internal nodes. So, the final property of the binary tree is the binary tree with L leaves, L number of leaves has at least log L plus 1 levels in that particular tree. So, let me check them. In the first diagram the number of leaf nodes are 2, That means the number of maximum levels allowed in this tree with the leaf nodes 2 is log 2, which is equal to 1. That is, only one level is there in this tree. In the second tree, the number of leaf nodes are 4. So, the maximum allowed number of levels for this tree is log 2 4, which is equal to 2. So, through this tutorial we have seen what is a binary tree and what are the properties of binary trees and types of binary trees. So, thank you for watching.